Hello everyone. The title of this video is Evaluating Logarithms. So in this video I'm going to be doing examples taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 6.3, called Logarithmic Functions, and I'm under the heading Evaluating Logarithms. And each example I'm going to be doing is going to be an example from the reading, or one of the try it problems from the reading, or one of the exercises at the end of the section that's related to this particular objective. Alright, so we have seen a couple videos now on logarithms, and I keep saying this, right? Logarithms are exponents. So when you see, the logarithm base b of x, remember this is like a function, right? The logarithm of x, like f of x, g of x. You have a function called logarithm base b, and then the input is x. What this is equal to, right? What the output is. And we've seen this, right? Like I said, I've done a couple videos now from this section 6.3 of this text. But here's what you're thinking about now. What the output is, what the logarithm's equal to, is an exponent. Right? Logarithms are exponents. But it's the exponent that you need to raise base b to get x. Exponent necessary to raise base b to and get x. Right, get the input x. Right, and we saw this, right? We said the log base b of x, if that was equal to an output y, remember that meant the same thing as b to the y power equals x, right? We were transforming back and forth, converting back and forth between logarithmic and exponential form in the previous couple videos I put out about this section. Alright, so all we're asked to do is, evaluate, find the value of these logarithmic functions, these logarithmic expressions, without the use of a calculator, right? So we'll talk about, using a calculator. We'll look at logarithms with a calculator in a later video. But for right now, I should be able to, basically the input, the number inside the logarithm, is going to be some nice power of the base, as we'll see with these. All these examples will be like this. All right. So example 1. What's the logarithm base 4 of 64? So you got to be thinking, 4 to what power equals 64? And that's what this logarithm will be equal to, this power. Well, we know, hopefully, that 4 to the third power, 4 times 4 times 4, is 64. So this is 3. The logarithm base 4 of 64 is 3. Since, and then changing to exponential form, you'll see that it's true. 4 to the third power equals 64, right? That checks out. That is a true statement. So this is true as well, right? They're equivalent. The log base 4 of 64 is 3, right? The number 3 would pop up in a calculator if you were to punch that in. Okay. And yeah, every single one of these is like this. So example 2. I have the log base, 121 of 11 equals what? So we have to think, 121 is the base. What power do I raise that to? Put a little question mark there, and get 11. Now you might recall that the square root of 121 is 11, right? The positive square root, the principal square root. Remember, square root is a power. Square root is the half power. right? So this is a half, and that's all they want. Right, and again, change it to exponential form and see if it's true, right? Since 121 to the 1/2 power is indeed 11. That checks out. So 1/2 is the correct result here, is the correct value of this logarithm. So again, logarithms are exponents. I'll say that a lot. Logarithms should be equal to the exponent that you raise the base to get the input. So here, the logarithm base 3 of 1/27th. I hope you remember your negative powers as well. Remember, 3 to the 3rd power is 27, but this is the reciprocal of that. And remember, the reciprocals are your negative powers. So if 3 to the 3rd, right, if 3 to the 3rd power is 27, then 3 to the negative 3rd power would be 1/27th, right? So the answer here is -3. Right? This logarithm is equal to -3. And again, that's because, this. If you were to change it to exponential form, it would look like this, and this is a true statement, right? 3 to the -3 power is 1/27th, positive 1/27th. Right, so the value of that logarithm is -3. And now we're moving on to this final example from this page. I got 3 more after this. And again, you're thinking the same stuff. Logarithm base 2 of 1/32. So 2 to what power? That's what's going to go over here. 2 to what power would be 1/32? Well, 2 to the 5th power is positive 32. And if you take 2 to the -5th power, right, we'll put this in exponential form, that would be 1/32, right? The reciprocal of 2 to the 5th. Remember, negative powers are just the reciprocals of the positive powers. And this works. So this is the correct value, right? The logarithm base 2 of 1/32 is -5, right? And that's because 2 to the -5 power is 1/32. All right, I got just one more page, a few more examples of this. All right, so we saw square root earlier with that square root of 121. So in example 5 here, I have the log base 6 of the square root of 6. All right, so again, you're thinking 6, right, the base, to what power equals the square root of 6? Well, that would be the half power again. So this has a value of a half. And again, if you want to translate back and forth, change it to exponential form, see if it's true. 6 to the half power, is that equal to the square root of 6? Well, yeah, that's what square root means, right? Raised to the half power. So this works. 1/2 is the correct value of that logarithm. All right, now these last two examples aren't just a simple log. It's a logarithm plus something or a logarithm times something. But you should still be able to evaluate the logarithm and then do any addition or subtraction, multiplication, division that you need to afterwards. So here we have the log base 2 of 1/8. So remember, this is what power do I need to raise 2 to get 1/8? And that would be the -3 power. All right, remember, 2 to the -3 would be 1/8. And then don't forget we have the plus 4 afterwards. And then simplifying completely, -3 plus 4 is 1. Right? So if you were to punch this expression into a calculator as it is, you'd end up with, it would output the number 1. All right, then finally, I have a logarithm, but it is, multiplied by 6. All right, now this one's a little tricky. I'll do this off to the side. The log base 8 of 4. Again, I don't know what this equals, so I'll say question mark. Remember, if you change this to exponential form, this means, 8 to what power equals 4. And then this is where some properties of exponents can come into play. And we'll see much more of this later in a later video when I talk about solving exponential equations. But both 8 and 4 are powers of 2. This 8 to question mark is the same thing as 2 to the third. That's 8 to the question mark equals, and then over here, 4 is 2 to the second power. And then on the left side, when you raise a power to another power like this, you multiply those. So this would be 2 to the 3 times whatever, 3 times question, equals 2 to the second. And then you're going to use the fact that exponential functions are 1 to 1 to say, hey, the only way two powers of 2 are the same is if their powers are the same. So 3 times question mark must be equal to 2, and then dividing by 3, the question mark must be 2/3. So this is the 2/3 power. Alright, so that's a little tricky, that one. But you may have to do this in some cases. Right? Because, the square root of 8 is not 4. Some people might be thinking that 8 times a half is 4. 8 to the half power is not 4. It's 8 to the 2/3 power is 4. Alright, and I'll write that up here, right? This is the exponential form of this. 8 to the 2/3 power would be 4. And remember how to raise the fraction powers? This means take the cube root of 8, which is 2, and then square it. 2 squared is 4. That checks out. Right? So 2/3 is the value of this logarithm. So and then don't forget we have times 6, right? We have 6 times this logarithm. 6 times 2/3 would be 4, right? So the final value of this expression, 6 times the log base 8 of 4, is 4. Right? Great. But yeah, so that was a little trickier. And if you don't want to call it question mark, you can call it x or something, or y, and then solve for y, like instead of solving for question mark. But whatever. As long as you understand what happened here, that's all that matters. All right, and that's it. So again, I'm hoping you understand when you're asked to find the value of a logarithm, you're thinking of what power, what exponent would I raise that base to get the input, to get the number inside. So here, 8 to the 2/3 power would be 4, right? So the log base 8 of 4 is 2/3, and then do whatever operations are there afterwards. All right, so I'm hoping that watching me go over these 7 examples here help you in some way when you're asked to evaluate a logarithm without the use of a calculator on your own. And thank you very much for watching.